I hope we have class on Wednesday. Some classes are short.
We do, but it's
Okay, but we have it. Thank goodness. Okay. So on Wednesday, and I'll put this in your assignment page to come on Wednesday with questions off of your review packet or Delta Mass or whatever that I've assigned for you. I think I've given you your review packet and shown you where to find it and blah, blah, blah. On Wednesday and Friday and Tuesday, we'll be reviewing for the exam. During that time, I'll probably also weave in some factoring that I think will be easy to do on the exam. I can always, if I don't feel good about it as a class, I can take that off and we can just put it on a later test, so it's not necessary. But I want to have that in there too, just because I really like to do that before spring break in Algebra 2. So woven into what we're going to be doing is some factoring, and we'll see how it goes. And I'll be able to tell, by different things. So reviewing for the exam will be the heavy duty stuff that we do the next 3 class periods after today. And so it's going to go best if you come just armed with questions. And I just take, you're like, on page 4 of the review, I want to do this, or I don't understand the Delta Math this. And you have, right, to get like a clean sheet of paper when you start to review or study. Get a clean sheet of paper where you're writing notes to yourself of questions that you want to ask me so you won't forget. Or if you print off the review, the hard copy, the paper copy of the review, if you print that off, it's good to maybe study with a highlighter to where you mark things that you have questions about so that we can go right to them. Bailey, did you have a question?
Oh, yeah, this isn't the review?
That's not the review. It's just the next unit. Okay?
So,
The review is posted under exam review under topics.
okay, yeah, that was
Okay. Let's look at that real quickly so y'all know where it is. I think I emailed it to you also, but if you go to your page and you go to topics, and some people remember that I've already shown you this, but this is review. If you click on the review, here's our exam review. By the end of the week, you'll see the solutions to the exam review up, probably in a couple of days, so that you can actually see if you're getting them right. But I just don't want to post them too soon I don't want to short circuit your own thinking. Okay, but you will have all of the answers to it certainly before the weekend, if not sooner. And also, if you go to Delta Math, remember this. If you go to Delta Math, and let me look at your view. So your Algebra 2 view looks like this. And you've got all this, like it says explicitly review for the exam. Let me make sure I've got transformations in there. Like the most recent one, level 2. Transformation of functions level 2, I don't think I put in here.
It says transformation.
Yeah, I've got it. Yeah, it's right here. Where'd it go? Mixed. That's what you had for homework. Okay. The Delta Math's awesome to practice. It can be overwhelming, the amount of study material that Marymount teachers give for things. I used to not give these big fat packets and just say study your test for the exam or something, but we give boatloads of stuff for you to pick and choose what you need to do the most, okay? I would say I would definitely pace myself through working the hard copy, like the review posted in topics, and then as you need extra practice and have more time, you can do that on Delta Math. That's my suggestion. Okay, so let's go to the slides for a second. All right, so there is a monomial. A monomial is just like x cubed, okay? Or 5x squared. Mono, I think a lot of y'all know means 1, okay? So there's a monomial. There is a binomial and trinomials that we spend a lot of time factoring, okay? I feel like I should scream this because so many students, including myself, didn't know this until it was a bit it was hard for me to unlearn something that I thought was correct that was incorrect. So girls, I'm going to say this really, really loud, and there's really no good way for me to write this, but I'm going to say it over and over again. Just because you can't factor it doesn't mean there aren't any answers. I didn't know that was true. If I said I can't factor it, I think I thought there were no answers. It means that there are no answers that you can think of real easily, like 5 times 3 or factors of 15, okay? Now, if I ask you if they're factors of 117, there are, but can we think of them really quickly? Factors of 117. But do y'all see the difference? Okay. Girls, sometimes the answers to a polynomial are very inconvenient things. Listen to me, like 5.86439. That might work in the polynomial, but it's not one we're going to be able to think of ourselves, okay? So what factoring does is it's a first stop to see if there's any integers or any, let's call them rational answers, okay? Another definition of a rational number just means it can be expressed as a fraction. Like, for instance, 7 is a rational number. Because couldn't I write that as 7 over 1? Okay. I'm not really wild about 11/17. Not really wild about fractions at all. I have 17 students in the room, and 11 of them might make an A on the last test, right? So even though I don't like the fraction, I certainly can rationally understand it. Do you see it's rational? Okay? Rational means that it can be expressed as a fraction. Okay?
Can't everything be expressed?
No. Like pi cannot be expressed as a fraction. Square root of 7 cannot be expressed as a fraction. Those are irrational. They go on and on. They never repeat. And there's no pattern. And they're just super weird. And we obviously would call those irrational. One reason I was late is I was having a discussion on the way up the stairs with Mr. Yang about how the transformations are common sense. And if you're trying too hard to memorize it, it's probably getting in your way. And we'll talk about that later. But irrational is like, that's weird. It never repeats. It never has a pattern. Girls, I think you know that pi, people have written it out to tens of thousands of decimal places, and they can't find the end or a pattern that repeats. Now, watch this, Bailey. This seems weird to me. Do y'all remember what that line over it means? Thank you. It's 0.3 repeating forever and ever, which kind of weirds me out. But I can understand it. It is rational because does anybody know how you can write 0.3 repeating as a fraction? It's 1/3. And I definitely understand 1/3 of your group had a cat or whatever. Okay, 1/3 I definitely can understand. I can have a big piece of cake and eat 1/3 of it. I can rationalize that. And so irrational means they are non-terminating, non-repeating. I'm never going to ask you for a definition, but it's nice to know what in the world it means when someone starts talking. There's never a little group of it that repeats, and so you can never write it as a fraction. Because if I can write it as a fraction, that means I can understand it. Think about that. If I have 123 over 999, I can understand that 123 people out of 999 might have voted for my candidate. Do y'all see that if I can write it as a fraction, I can understand it? By the way, girls, you know what this one does up here? This goes 0.123, 123, 123. Right now, don't do it, but someday you could type it into your calculator, 123 over 999, and it'll go 0.123, 0.123, 0.123. Now, it's non-terminating. It never ends, but it does what? Repeat, okay? So if we can't find a repetitive pattern, and it never ends, our minds are blown, and we say that's irrational. So let me finish what I'm saying, and then I'll take Bella's comment. What I'm saying is that if you're trying to factor something, You're looking for rational answers, okay? There might be irrational answers or difficult answers that you would never find with factoring, and that means there's other ways to do it, okay? Factoring usually is in the case of eventually you're looking for zeros. So say I have this parent graph. Can y'all actually see these numbers? Do y'all see those red zeros? That's usually what you're looking for when you factor, okay? When we factor, I'll keep reminding you all year from here on out, all factoring does for you is look for the easy answers that we call rational. It doesn't mean that there's not other answers out there. It just means, girls, that's our first stop, okay? 117 has factors, just like 15 is 3 times 5. 15 is really easy to factor. Is 117 easy to factor? You probably want me to let you use your calculator, right? Do y'all see the difference? It doesn't mean it doesn't have factors. It doesn't mean it's what we call prime, okay? All of those things we've got to talk about as time goes by. Fortunately, you don't have to deal with it tonight, okay? Or, yeah, for homework Wednesday. All right, so just a big deal before I go on. I'm going to circle it in red. Factoring is just your first stop in looking for some zeros. It's your first stop looking for some answers. Teachers have to teach you other things in case that doesn't help. It doesn't mean there are not any more answers. And that's pretty much news to a lot of people. They think, oh, well, it won't factor, so there's no answers. It just means there's no easy answers. Okay? Just a side note, does anybody know how I know that 117 has factors other than I'm a math teacher?
Well, I think they're factoring rules, right?
Yeah, because I think that so 7 plus 2 is 9.
It adds up to 9, so it's definitely divisible by 3. If you have a number that adds up to a multiple of 3, it's definitely divisible by 3. Yeah. So like this.
Wait, say the rule again.
No, that if you add a number up and it adds up to
So something is
digits
divisible
of
by
a
So if you add the digits of a number up and the number that you added up is divisible by 3.
This big old huge number is definitely divisible. I'm gonna, hey girls, I'm gonna show you. I'm gonna show you. I'm gonna show you. I'm gonna show you. Thanks for helping each other. This one's definitely divisible by 5. So 5 is a factor of it because it ends in a 5. It's got to be a factor of it. Also, 3 is a factor. This is what girls are trying to tell you around the room. 3 is a factor of this because if you add up the digits, this is 10, 1 plus 2 plus 7, and this is 11. And so the total, it adds up to 21. Isn't 21 a multiple of 3? If the numbers add up to a multiple of 3, then it's divisible by 3. It's a really cool rule. Okay?
No.
Oh no, okay, that makes sense, sorry. I was like,
So let's see. Let's take 1, 2, 7, 6, 5 and divide it by 3. 3 goes into 12 4 times. Bring down my 7. It goes in 2 times. Bring down my 6. It goes in 5 times. Bring down my 1. It went in evenly. If the digits add up to a multiple of 3, it's divisible by 3. Thank you, Yana. All right, now girls, we're not going to sit around in 9th grade and factor numbers. So let's move on to polynomials. So let's go back to my slide up here. In fact, I'll start a new one. That one's gotten kind of messy. This is where we need to be. That was just discussion. There's monomials that have one term, like 5x cubed. What would a binomial, when I say the word binomial, that just means it has how many terms? Bicycle? 2, okay? So 5x cubed plus 4. That's a binomial. So what's a trinomial? What's a tricycle?
3.
It'll have 3 terms, like 5x cubed plus 4x plus 7. After that, I've never heard of a quadnomial. We just call them polynomials. What does poly mean? Many. The word actually means many, okay? Ironically, underneath polynomials, if I say polynomial, I might even be talking about a binomial, a monomial, or a trinomial. It's a catch-all word for these kind of things that you see on the sheet that I just handed out. Okay? So it's like you're all Marymount students, but I could be a little clearer and say class 9 or class 12, and then within that I can be even clearer, but it doesn't negate the fact you're a Marymount student if I know your name and I know what class you're in. Okay? So a polynomial is the big subheading. It's just like in history if you're studying the Reconstruction or something. It's just the heading, and underneath it are subheadings that not a big deal. I'm not going to ask you for the definition. But if I say I have a monomial, I'm being a little more specific. You know, I have one term. If I say I have a binomial, I have 2 terms. If I say a trinomial, you have 3 terms. I've never heard of a quintinomial. That would mean we'd have 5 terms. We just, at some point, we just go whatever. I have a polynomial, okay? So that we know our words. Okay, now, get out your packet, turn in, oh, Bella, I may have skipped over your comment. What were you going to say?
I was gonna ask if we're gonna have our calculators for the exam.
You'll have them. We don't use them much. You'll also have a note card that I'll tell you probably on Wednesday what you can have on the note card. I don't have any rules for the note cards, but I abide by the rules of the Math Center. The reason I don't have any rules for the note card is before I ever came to Marymount, there's no way I'd ever let you have a note card during an exam, but they let you have one here. So anyway, that was foreign to me 6 years ago. But you'll be able, it'll be, I think, a small one. I'll hand out 3x5 note cards. And there's certain things that other teachers don't want written on there. Like, I'll tell you what you can write on your note card,
Do you
okay?
get that for every class? Like,
I think it's just by
Probably
department.
just
It's by department. Okay. Let me tell you this, just as a side note. If you're heavily dependent on your note card or your calculator, you won't do well on the exam or the ACT or the SAT. Knowing the material, most of my students last year would tell you they didn't even look at their note card. Like they knew the material, which is a great study tool to get out a blank sheet of paper and write your stuff down. It's a great study tool for any course. So now once you've written it, all your teeny tiny stuff on the note card, you probably know it. If you copy someone else's note card, it probably is not going to help you because it's not going to be in your brain. You're not going to even know where to look. Anyway, that lecture's over. All right, so look at number 1. Okay, so the first rule of factoring. Okay, first rule of factoring. I'm going to use, who's going to be my new Kate Unrath? Who volunteers to be my new Kate? Okay, Ella, you talk a lot. I want somebody that doesn't talk a lot.
Did you know Kate and I live in the same building?
Oh, well, that's a reason to choose you. All right, I'll choose Margot. Margot, what's the first rule of factoring? Every time you see a polynomial, you say take out what's in common. That's what you respond for the next 4 years.
They take out what's in common.
Yes. So when y'all see Margot, you can go, hey, Margot, what's the first rule of factoring? And if you already asked Kate Unrath that, she'll say take out what's in common. Okay? So you'll see why later. I'm making a big deal about that to where we even had a little activity. Okay? Number 1, xy minus xz. Notice what is it? Oh, by the way, girls, it'll just say eventually factor. It won't say how. Okay? It'll just say factor. I think, Bella, you said this a second ago, GCF, greatest common factor.
That's why.
Okay?
I think that's why I thought we were doing the
That's why we were doing that. Okay? Do these have anything in common? What do they both have in it? X. Did y'all see how you just said we painted our fingernails, we have blue sweaters? You told me an item that you all had. So I'm going to take it out here and leave y minus z instead. That's factoring. That's your first rule of factoring. Now, do y'all see how all of a sudden I have found a way to report what those had in common, just like y'all did for me? You have a parent that was born out of the country. But I know that meant it was Victoire, Gabby, and Yana all had it, okay? People's fingernails are painted. I know that all 4 of these girls have that, okay? So, do you see that I could redistribute it? Wouldn't that be xy minus xz? But what we want to do is go, oh, all of these people in here have this item. All right, try number 2. Oh, by the way, this is the answer to number 1. X times Y minus Z. Go across and try number 2. Well, I'll write it up here. Number 2. Y'all are such an awesome class, by the way. Do I tell y'all that once a week? I hope. Okay. Raise your hand if you want to tell me everything they have in common. All right, Daniela. Well, you want to go for it? You kind of change your mind. All right. Listen to Evelyn. What do they have in common?
Well, they both have in common the 3.
Girls, watch. I'm going to pull it out. I'm going to report it. And anything else?
And
What else do they have in common? X. Okay. So they have a 3x. If you take a 3 out of 9, what's left? A 3. If you take an x out of x squared, what's left? X. And what happens if you take a 3 out of a 3?
0.
1. And an x out of an x? Wait a minute. What's x divided by x? It's 1. Okay? Hey, girls, you can check every single answer. How can you check your answer? Can't you redistribute? Okay? I think redistribute is not the right word. Distribute. Look, girls. Would that give me 9x squared minus 3x? Okay. So watch what I'm doing. Watch my hands. I'm taking a 3x out of this. And what happens if you take a 3x out of a 3x? Many students sometimes say it leaves you 0. If it left you 0, that means it was never there in the first place, so that doesn't make any sense. Everybody listen. Stop looking at your worksheet. Thank you for being anxious to work ahead, but listen up. When you're factoring, you're actually dividing in your head. Okay? So if I have 9x squared divided by 3x, do you see 3 goes into 9 3 times? X goes in x squared x times. So you report what they have in common, and then you write what's left over in the parentheses. You can check by distributing. All right, number 3. Raise your hand if you can tell me if number 3 has anything in common. Ella, what do they have in common?
3.
All right, so 21b minus 15a. Let's go back to something that Bella noticed when we started class. Greatest common factor. You want to take out as biggest thing as you can, and I agree, 3 is the biggest. Do they have any letters in common? Okay, so don't lose the 3. You need it. You're just saying you're pulling it out, okay? Now, if you take a 3, if you divide 21 by 3, what's left? 7b minus 5a. And then you can mentally redistribute. Hey, girls, double check. You haven't done it quite right. If these still had something in common, you may have accidentally missed your greatest common factor and go, oh, I need to pull that out also. You can take another step if you need to. All right, questions, comments, Yana?
So if them, if in the parentheses they don't have anything in common, then you know that.
Then we'll see what else to do. That's not for today. But listen up, girls. Yana's asking a question that's going to come up later. Is I've looked at it. There's nothing in common. What do I do now? And right now, I'm not even finding what we call answers. Okay, which maybe I should. Right now, you don't even really see the goal in this. And I'm going to wait on that. Let's keep going. Let's just do one thing at a time. All right, number 4. Raise your hand if you know what number 4 has in common. All right, Bella?
9y squared.
All right, 27 and 18, the biggest thing they have in common is 9. And they both have a y squared in them, 2 y's. All right, what's 27 divided by 9?
4. 3. Oh,
3.
sorry. 3. Sorry.
And Bella wanted to take out 2 y's, so what's left? A y. What's 9 out of 18 divided by 9? 2. And we took out the y squared. Okay? So it's really like this. This is overkill. You don't really have to do this. It's too much, but watch this. 27y cubed plus 18y squared. Sorry, I'll change colors. 27 is 3 times 3 times 3. Y cubed is y times y times y. 18 is 3 times 3 times 2. Are y'all okay with that? 3 times 3 is 9 times 2 is 18. And y squared is y times y. How many y's do they both have in them? Don't they both have these? So you factor it out to the outside. So, sorry, I had a hard time reading that red probably. So we take out two y's. Y times y is y squared. What else do they have? Don't they have this 3 and this 3? What's 3 times 3? 9. And can you see what's left behind is what color is what's left behind? What color is? Everything that's left behind is yellow, right? And so that's 3y plus 2. So do you see it's the same answer as we got up there? You could do it this way every time, but I think you would fall behind, okay? I'm not saying that you need to do that, but if you're having trouble understanding what we were doing, that's what we're doing. All right, Rebecca, can you tell us what's in common on number 5?
Yeah, 4x.
All right, so very good. They both have a 4 and an x in it, and you divide. 12 divided by 4 is 3. X squared divided by x leaves me an x. What's 16 divided by 4? 4. And you already took out the x. You took it to the outside. It's accounted for, okay? Y'all okay so far? All right. Let's go to number 6. Number 6 is 28x to the 5th minus 7x squared. Sarah?
How would they have 7x squared in common?
They have a 7 and an x squared. Very good. All right, what's left?
Inside.
Uh-huh.
4x cubed, and then minus 1.
Make sure you have that minus 1. It's not a 0. It has to be a 1. Watch this. If you redistribute, do you see that 1 has to be there? It's a placeholder for what you've factored out. All right, number 7. Somebody new, number 7? Let me write it down and I'll look up to see who's volunteering. Okay, Gabby.
I have 7x squared.
Wait, on number 7.
Oop, my bad.
Yeah.
Sorry. 2xy.
All right, so she sees a 2, an x, and a y. Anything left behind in the front? What's left behind in the front? Gabby took out a 2.
Well, I did x minus 1.
Okay, that's what I'm asking.
Oh,
Okay.
Sorry. Yes.
If she took out an x, how many x's are left right there? There's an x minus 1. So do you see she took out a 2xy, and this one had 2x squared y. I don't feel like I explained number 7 very well. Are y'all okay on number 7?
No.
Okay.
1 is, well, 2 times 1.
All right, Victoire, look up here, and probably some other people. 2x squared y minus 2xy. You're pulling out just like you're going to report to me what all these people have in common. You'd go, oh, well, they both have a 2. Anything else they both have?
The xy.
A what?
xy.
XY. Okay? That's what they had in common. One thing I maybe should have done in the activity is some things you didn't have in common because that's what's left behind, okay? So, I don't know, do you have a dog, Victoire?
No.
Okay, do you have a dog? Do you have a dog?
I have a brother.
Do you have a brother? You have a brother. Okay. Do you can't think of okay. So you have like a I don't know a scarf on your head. Okay. So what's in common is I would say you have blue sweaters. I would take that out. But what's left behind is you have a scarf on your head. Okay. She likes purple apparently, and you've got like a plastic bag. I mean, or really cool shoes, really cool Asics, okay? Do you see what I mean? How you're pulling out and you're writing down what the people still have. This their very own, okay? So this one did have a 2xy in it, but it had something else of its very own, which was what?
The square.
Okay, if it's x squared and you took an x out, how many are left? Okay? And then you see the minus sign?
Yeah.
And if you take 2xy out of 2xy, what's left behind? 1. So that's what I was saying. You may have understood that in the first place.
Yes, this makes sense.
All right, Maria?
No, I just have a
You want to do a question?
for number 8, like I know.
Okay. Let me write it down, and you can give me the answer, and then I'll take your question. This is number 8, girls. All right, Maria?
So the answer is 8m squared.
Good.
And then the parentheses has n plus 2n.
Perfect.
So I wrote like before, I wrote 4n squared and 2n plus 8n.
Then you see they still had something in common?
So that's
That means you're not finished. Is that what you're going to ask me? Okay. All right, number 9, anybody? Number 9, Rebecca?
2b.
All right, let me write it down. All right, so they have a 2b in common, so you're pulling it out. What's left behind here?
2b squared.
All right, what's left?
Plus 1b plus 4.
Okay. Everybody okay? All right, let's go to the second page. Number 10. I have to get you used to, especially for standardized tests, is they could have an entire expression in common, okay? Like, I'll do the first one. Do y'all see these both have,
This is not the whole thing. So they're like double parentheses.
okay, hang on, I'm going to do it. Do y'all see they both have the expression x plus 2 in it?
Yeah.
All right, they both have an x plus 2 in them. And so I'm going to take out the x plus 2. If you take out the x plus 2 from the front one, x is left. If you take the x plus 2 out of the back one, what's left? 7. And you need to put them both in parentheses. Why do you need to put them both in parentheses? What if you didn't? Technically, what's being multiplied to this x plus 7? If I don't put it in parentheses, do you see it's only the 2? That's why you got to put in parentheses and say they had the whole thing in common. And then you could just leave it like that for now. Okay? So you're pulling it out and write what's left behind. Any questions so far? All right, Bella?
So it's like the last step when you're factoring like a trinomial.
Yes.
So like instead of doing everything else.
Yeah, but don't multiply it out.
No.
It's already like, it's really factoring by grouping.
It's like where you factor it. Yeah, yeah.
It's like factoring by grouping. A lot of y'all may have done that before. All right, Yana?
So would you also just distribute regularly?
I wouldn't, because then it's going to make it a whole lot harder to factor. You see what I mean? It makes you feel like you should distribute, doesn't it?
Yeah.
But don't distribute. In fact, you can hold off on that more as you get older, because I feel like in middle school, so often we hand you something in parentheses and you distribute like crazy. And then I spend a lot of the high school time with you going, don't distribute that because you want to see it. Okay? Like, what do you see automatically that 11 has in common? X plus 4. Okay? So I'm going to take it out and put in parentheses x plus 4 and write what's left. If I take x plus 4 out of this one, 2x is left. If I take x plus 4 of that one, minus 3 is left. Daniela, did you have a question a while ago?
I was just gonna ask if you could turn off this light because it's kind of hard to see.
Yeah.
Can you just switch them?
Yeah.
But then it's gonna
It's gonna be worse.
Yeah. Just try it.
Try it.
I kind of like it. That's the same.
So you turn it off.
It's going to be too dark for some people. They,
so nice.
it does. That does.
Yes, from
Hey, Daniela. Wait, Susan. Yeah, go on and sit down. If you'll switch them, do it.
We can't really see it.
Everybody sit, except for Daniela. Okay.
No.
You've got to realize that for 6 years I've taught in this room without a problem. Okay, so we're not going to play with the lights every single day, even though you're a fantabulous class. Was this the way it was when you asked me to change it? Change it the other way, and let's see how the other side of the room is doing.
That's worse.
No.
Yeah, I really don't want
We just go back.
to. Do you see? No.
There we go.
All right, Daniela, what's happening? Like, what? Can you not see that?
There's just some glare.
There's a glare from the lights.
Yeah.
Okay.
We just from the projector.
Okay, so thanks. I just want everybody jumping up doing things. If you'll, are side lights okay with everybody?
Yeah.
Let's do it for the last 7 minutes of class.
Oh, that feels so nice.
Okay, and now there's a glare also still, but let's keep.
It's still there.
All right, number 12. Number 12 is 4x times x minus 3y minus 2 times x minus 3y. All right, I'm going to do this one. Do y'all see you have an x minus 3y in common?
Yes.
You're factoring it to the outside. You're not losing it. You're just going, we all have this.
Yeah.
If you pull it to the outside, it leaves you a 4x minus 2. Okay? Sophia, you want to do 13? Tell us the answer to 13.
I got open parentheses 2a minus 3b close parentheses open parentheses 5a plus 6 close parentheses.
Thank you. Who wants to tell me their answer to 14? Or let's do it together. What does 14 have in common? 4n plus 1. This is a little trickier. And we'll have to take one more step on this one. If we take out 4n plus 1, the front has 3n plus 1. What does the back have? n plus 2. Do you think I want you to leave it that way? What would you naturally do to the back part? Add like terms, and that gives you 4n plus what? 3. Very good. All right, on 15, what I want you to do with that minus sign is circle it because it's dangerous. Your minus sign can be very dangerous, okay? Do y'all all agree that it has an x minus 4 in common?
Yes.
So I'm writing x minus 4. Okay? And what's left, watch this, girls, is 2x plus 5. Watch my pen, don't write. Minus x minus 4. Did y'all see what I did with that scary minus sign? Everything behind it has to be subtracted, and if you don't put the parentheses, you won't get it right. Did y'all see the difference? So what I'll probably do on worksheets and exam and stuff is I might get you through and let's circle some dangerous I just spilled water on the computer. Do y'all see a Kleenex or toilet paper or? Thank you. It's just a little bit, but still. Yeah.
Why don't you do the 5x plus 2 and the 2x plus 5?
Because they're not alike. 5x is not the same as a 2x.
But like for number 14, we combined 3n plus 1 plus n plus 2.
Those were added.
Oh, so if it's subtracted, then you have to use the thing that's alike.
I don't feel like I answered your question. Did you answer your question?
Yeah.
Okay. Okay, thank you. All right. So, girls, I'm not. I think I misunderstood your question, Bella. I'm not finished with this.
No, you just
Yeah.
combine you multiply the negatives with the x minus 4, and then you combine like terms.
Right. Very good. Hey, girls, listen up. So now in this parentheses, I have 2x plus 5. Watch. Minus x. What happens if I subtract that negative 4? It becomes positive 4. You have to be really careful with your minus sign. That gives me x minus 4 times 2x minus x is x plus 9.
Wait, so why do you just leave the 5x plus 2?
Like, where does it go?
Oh, whoa, I'm sorry. I don't even,
That doesn't make sense.
yeah. That was horrible.
That's why I got so confused.
That was horrible.
Is it 2x minus
Sorry.
Would it be 2x minus plus 5?
They have an x minus 4 in common. So sorry. What's left? I was so upset about the minus sign that I just messed this up
So
totally
would
for
it be
you.
2x plus 5?
Hang on, Bella. Time out. I'm going to say what it is so everybody can hear, so we're not talking over each other. Girls, the minus signs will hurt you. Be really, really careful. Susan, y'all need to watch this. The minus signs are going to, they can make or break your test, okay? Forever, not just in here. This said, thank you, Bella, for continuing to ask me. This said 2x plus 5 times x minus 4 minus x minus 4 times 5x plus 2. Thank you for staying with your question. They both have an x minus 4 in it, so I factored it out. This is scaring me. It should scare you, okay? What's left behind here is 2x plus 5. What's left back here is a 5x plus 2. But it was meant to be what? Added or subtracted? Do you see how I'm going to miss that? Right now, the only thing I'm subtracting, see this? Right now, I'm just subtracting the 5x. I was supposed to subtract everything. That's why I said put it in parentheses. And so what I actually have is this, x minus 4. This is 2x plus 5 minus 5x minus 2. You got to subtract, subtract, subtract. So my answer is x minus 4. What's 2x minus 5x? Negative 3x. And 5 minus 2 is positive 3, isn't it? Oh, this is interesting.
I think the 2 is positive.
Yeah, the 2 is
Did I copy it down wrong?
No, the second thing we got.
This one?
The last one. Yeah.
No, that's what I keep trying to say. You're supposed to subtract both of those.
Yeah. You can-
That's why I was making a big deal while y'all were kind of talking back there.
When they put in a parentheses, I think the number on the side.
Sophia, this says, when you have this, we had 2x plus 5 times x minus 4 minus x minus 4 times 5x plus 2. When you take out this x plus x minus 4, wait, some people aren't looking that really need to look. When I take out, yeah, it's got to go to the whole thing behind it. So what's left is 2x plus 5. The danger is you're going to just say minus 5x plus 2. You need to say minus 5x minus 2. Do y'all see what I'm saying? Okay.
If you're multiplying the negative into the parentheses, the parentheses of the 5.
Wait, everybody hold still.
So it's just-
We're not finished with this problem. But you probably also need to hear Sophia's question. All right, go ahead.
If you're multiplying the negative into the parentheses, the one with the 5x plus 2, then shouldn't it be negative 5x minus 2, but the negative's outside the parentheses, so shouldn't it be positive 5x?
No, you're doing too much to it. That just says subtract 5x. If it was a minus a negative, then it would be a positive.
But the negative doesn't like.
What's going to happen if you have minus 3 plus 4? I'm not going to call that minus negative 3. That's just minus 3 minus 4. Like, Sophia, I'm supposed to just do this. When the x minus 4 is gone, I'm supposed to say minus 5x minus 2. It sounds like you're doing some sort of extra minus thing to it.
Well, if you have like a negative outside the parentheses, the negative doesn't go away once you multiply. And if you have negative, then it should be positive, right?
We don't have negative negative.
Why not?
I don't know where you have a negative negative.
I have 2x plus 5 negative in parentheses.
Okay, never mind.
Are you sure? We'll look at it. Do you have a class right now?
No.
Okay, we'll look at it. Bye.
Well, I'll have a
Check assignments. Sophia, come up here and let's look at it together real quick.
Is the topic the homework or?
No, check assignments for homework. It's not up yet, but it'll be Delta Math, okay?